and I'll be taking the session. I'll be taking the session for today. And so before we begin with today's concepts about bioplastics, would anyone like to revise or recapitulate what we did in the previous session? Anyone who was there last time? Ayana, Mihir, anyone? Ranil? All right. No problem. So, okay, yeah, sure, Ranil. Go.
So we discussed about green chemistry, so the basic principles of green chemistry, and we even played a small game about
Hmm.
various products of green chemistry. And yeah, so for example, if you remember, we even discussed about coffee, nail paint, and many other stuff.
Right.
So
Right.
yeah.
So we basically looked at many concepts of green chemistry and how we can relate them with day-to-day products, like as Sunil mentioned, nail paint and any biodegradable product, coffee, etc. So to just quickly maybe emphasize more on the previous session's topics, we will start with a small quiz for everyone. I hope you all can access quizzes, right? Can you all access quizzes on your devices? All right, great. Uh, Ma'am, could you please enable screen sharing?
Yes, I'm so sorry. Just give me one more. Angad, just check if you can share now.
Yes, ma'am. So people can like you all can join on this with this game code. I also share the link with you all to join directly. Wait for you all to join, and then we'll start with the quiz. Great. So we see a bit there. Yeah, we have a few people left. We could just join quickly and then we'll start with the quiz. Abhijay and I think we can start, right? Huh? All right. So, okay, right. I think now we can begin with the quiz. So, the first question. Green chemists reduce risk by reducing the hazard inherent in a chemical product or process, minimizing the use of all chemicals, inventing technologies that will clean up the toxic sites, or developing recycled products. You have around 15 seconds. Okay, so the time is almost up. 3, 2, 1.
Sir, I see a different question.
Sorry, what?
Yeah, I
I
think
see a different question. Like you're not playing. It's not like a Kahoot. So people will actually see different questions on their screen.
Yeah, right.
yeah,
How could
it's
I?
okay. I think okay, just check the settings once, Angad. If not, we can perhaps attempt all questions and then we can discuss them one by one in like quickly later once everyone has attempted. What do you think?
Okay, all right, yeah.
Huh?
So sorry for the confusion.
No problem. We can do.
Then yeah, so you all can do the quiz on your own at your own ends, and let us know when you're done.
Oh, I can see Ayana, you stood first in leaderboard. So cool.
Ma'am, I'm third, but I would have been second if you didn't join.
Oh, yeah.
I kind of forgot some of the stuff.
I think most of us have attempted, Angad. So if you want to just quickly go over the questions once and then, so that we can discuss them briefly. Angad, I think you're on
Angad,
mute.
on me.
Oh, I was on mute. Sorry.
Yeah, no problem. Go ahead.
Right. So there are four options, and you have to look at which one would fit on the left. So basically, we have to add a word with each of these waste materials, environmental impact and cost, and which would fit. And the right answer out of the options was reducing, right? So like reducing waste, reducing material, reducing risk, environmental impact and cost. Any doubts over here? Could we move ahead to the next one? All right. So then, green chemists reduce risk by what do they do to actually reduce risk? They reduce the hazard inherent in a chemical product or process. Yes, that's what was in the principle safer solvents, right? Where we use very like safe chemicals and we avoid chemical byproducts, which are harmful. Minimizing the use of all chemicals? No, not all chemicals. Developing recycled products? Maybe not always. And inventing technologies that will clean up toxic sites? No, that's not what green chemists do. So the answer was reducing the hazard inherent in a chemical product or process. Going on to the next one. The following is often referred to as the universal solvent and is a preferred green solvent. So basically, this from all the options was water because that's the most safe solvent that we have for chemical reactions, and water in any form which is available in would not harm the environment, right? In a liquid form is simply water, solid form is ice, and the gaseous form is water vapor, which will again not harm the environment. So the answer was water here. Similarly, This green chemical is often used in household cleaners to remove stains and is also a favorite dressing on salads. This was vinegar or acetic acid, which is its chemical name, scientific name. Then we had the term used to measure a product or person's environmental impact. This is a very common thing which we heard of, which we hear of the carbon footprint, right? CO2 footprint. And coming to the last question, the second last question, which of the following gases was traditionally used to bleach paper, right? And this was, I think, slightly tricky. The answer was chlorine. So chlorine gas was used to bleach paper earlier because it has good oxidizing properties. It can oxidize, or it can basically add oxygen to other elements, or it can take away electrons from other elements. And nowadays, H2O2, which is hydrogen peroxide, also known as heavy water, because it is a chemical which is very hazardous. So H2O2 with a suitable catalyst is used for bleaching purposes, as it does not contaminate groundwater. Similarly, this is the last question. Which of the following is a component of nail polish and can be absorbed through the skin and affect the nervous system? This is something we discussed in the previous session, and the chemical's name is toluene. Does anyone have any doubts? How did you like the quiz? Like, are you all now prepared for the next upcoming experiments? Right, yeah, I guess so. Great. Thanks, Abhir. So, we're going to start with uh, today's session officially, like today's topic to be done. Could someone please confirm what screen can you see? Pranay, Dushima?
I can see your slide on
Yes, we
bioplastics,
can
the
see your
title slide.
presentation.
All right, great. So we're going to start with bioplastics today. Now, does anyone know about bioplastics, or has anyone heard of bioplastics ever, or biodegradable plastics? Has anyone heard of it? Anyone? Mir, Abhivir? No? All right, no problem. So bioplastic, as the word suggests, it can be broken down into two, right? Bio and plastic. So bio is basically related to our biology, our ecology, right? Our environment. And plastics is plastics, right? The chemical which we use in our day-to-day products, like toothbrushes, plastic bags, etc. So bioplastics are the future plastics because they're the plastics which are biodegradable. We'll get into more detail in the upcoming slides, but they're basically plastics which are environment friendly, right? And we'll learn to make them with green chemistry principles and very easy household products, materials. Sorry. Right. So now, what exactly are plastics? Now, the scientific definition is very complicated, right? There's synthetic materials that consist of polymers, and they have many properties like durability, and they're not reactive. They have poor conduction of heat, electricity. This is very technical. Now, if we understand this definition properly, basically synthetic means something which is chemical, something which is not natural. That is synthetic. Polymers are materials that consist of huge molecules, basically huge combined atoms, right? So when a lot of atoms combine together, and there are many such groups of atoms or many such molecules, those materials, those compounds are called polymers. A small thing for you all to do, could you all bring any one plastic item around you? Any one plastic. It could be a bottle, could be a toothbrush, anything. Maybe a plastic cover on your notebook. All right. So I see a few small like tiffins, boxes. right? With Ayana and Adhir. I think Mihir has gone to. Okay, right. Plastic bottle, right? So these are certain day-to-day products which have plastic, right? Which are made of plastic. Very nice. All right. Now, types of plastics. So basically, we're learning about plastics. So we'll get into some detail with the types of plastics. There are two plastics: thermosetting and thermoplastic. And they do very easy types. Thermosetting are those plastics which do not melt, right? We know that there are substances which on heating will melt. They come into their liquid form. For example, ice melts into water, it comes into its liquid form. So plastics which do not melt on heating, even at extremely high temperatures, they're thermosetting and they can't be remolded, right? Because they can't melt, so they won't be able to be put in molds and then reshape. There are two examples: melamine and bakelite. Melamine is used like melamine basically has more insulation to heat. Insulation is basically resistance, right? When we don't want heat, that's called insulation. That's called resistance. So melamine is used for tiles, flooring, kitchenware, right? As you can see, there's another type, bakelite, right? So bakelite is that one which has more insulation to heat and electricity. And as you can see in the picture, there's a kitchen handle here, right? So you must have seen that in your pans, cookers, everything. There are these kitchen handles, and they have this different metal, right? Other than this part, they have a different metal for metal for the handle. So that part, that substance is basically a thermo setting bakelite plastic. Does anyone have any doubts here? Have you all got it? Okay, great. So now we come to thermoplastic, which is more relatable, right? Because we see it all around us. Most of the items which you guys brought, plastic bottle, plastic box, dabba, all these things are thermoplastics because they can melt. If you don't try this at home because it's not recommended, but maybe in a proper environment, if you heat your plastic bottle, if you heat your plastic box, it will melt. It will become into liquid plastic, and therefore they can be remolded because they will turn into liquid plastic. Examples are polythene, PVC. PVC, you must have seen PVC pipes, right, around your house. PVC is basically polyvinyl chloride. They're basically a harder form of plastic, right? And as you can see, there's a tape here, plastic bottles, construction pipes, right? Bags, all these are thermoplastics. Can we move ahead? All right, great. So now this is a very simple, interesting thing to know about how exactly we handle plastics, right? We hear that plastics are not good for the environment, but why are they not good? If anything is not good, it depends on their handling. It depends on their treatment, right? So there are four ways how we can treat plastics. One is dumping, right? In dump yard, in landfills, we just dump plastic there. It occupies space, it even pollutes the environment, and it harms wildlife because it takes away their habitat. It even, releases certain harmful gases like methane. And methane is a greenhouse gas, right? Do we all know about greenhouse gases and global warming, right? Climate change, right? So methane and carbon dioxide are those gases, and carbon monoxide as well. They are those gases which are released by burning or dumping or or burying, sorry, of plastics, and that's how they harm the environment. Similarly, by burning of plastics, the fumes which are released, as I said, they're very harmful. Burying also leads to ill effects on the microbes because the microbes, which are the microorganisms, the tiny organisms in the soil, they try to degrade the plastic. Why? Because they think that the plastic is their food. They will try to eat the plastic, but they're not able to because the plastic is actually not their food. So therefore, even burying is not a very good thing to do for plastics. As you can see, they have made a small ditch sort of thing in this area, and they have buried all the plastic in it. And this is also very harmful. We'll think कि अरे हमने तो bury कर दिया, now the plastic is gone, right? Now we can't see it, but it is degrading the groundwater and the soil underneath. So finally, recycling, right? Now we don't want to do we don't want to dump, we don't want to burn, bury. So how about we recycle? Now this is definitely the best option, but it is not very feasible at a large scale, right? We can't recycle every single thing of plastic which is around us. That would not be economically feasible, right? The infrastructure is a lot, the expense is a lot. So therefore, the first three, dumping, burning are the major things which we do. Can I move ahead? Is it clear till here? I know you're all excited for the experiment, and we're just coming to that in a few more slides. All right. Now, this is a very important concept of microplastics. Now, has anyone heard of microplastics here? Any idea about microplastics or what it may sound from the term microplastics? Anyone? Okay, no problem. Pranil, any idea about microplastics?
I can just ask anyone, is it
Yes.
microorganisms? Microorganisms, does anyone know what they are? Okay. All right. Okay, if I say micro means very, very small. Okay, then can you guess what microplastics are and where do you think they could be found? Yes, Mihir, please go ahead, give it a try.
So like I don't know, like in movies, like I've seen like some like people like take some things and take the help of some machine, like they can like just see some particles in that, and if like they take plastic, like they can like also see the microplastics which are like too small and we can't see through our own eyes.
Right. All right. Interesting. We cannot see them through our eyes, but so because they are very, very small. All right. I think Angad can take over from here. Pranil, you want to add something? You had raised your hand earlier.
Yeah, so like as the name suggests, microplastic means like micro means really small. So like as mentioned in the slide, they're very less than five millimeter in size. So like yeah, I know I have heard of microplastics and they are used in many fields. One example I would say is in the medical field, for silver nanoparticles. So yeah.
Great. Thank you. I think Angad can take over.
Yeah. So yes, as you both very rightly mentioned, microplastics means very, very, very small plastics. And yes, they are less than 5 millimeters in size. Now, who can tell me how much a millimeter is in terms of centimeters? Does anyone have any idea? Okay, no issues. It's half a centimeter, right? So a centimeter is this much, so it's half of that. So those plastics which are even smaller than this small a size, they're called microplastics. Now, why would they cause a problem to us? They're so small, right? So these microplastics, right, when they're exposed to extreme UV radiation, which we receive from sun, and even other factors, they can become as small as a red blood cell. Now, in our blood, we have cells, right? We have red blood cells. So they're extremely tiny. You can see them barely through a microscope. So they are very, very, very tiny. And these microplastics, they can become even tinier in the size which they are visible by the naked eye because you can see a centimeter, right? But plastics, microplastics, which are reduced to the size of a red blood cell, they are even more small. Then they have even started to be found in air, dust, food, drinks, honey, sea salt, etc. Basically, the things you eat, they contain these microplastics. Chemical additives, basically, this is something which we add to something, right? For example, if maybe we have a soap, so we add fragrance to it. So that is a chemical additive. We are adding a chemical to enhance the chemical properties. So a chemical additive in plastics called phthalates has been found in about 80% children and nearly all adults. And this is not a very good chemical, right? It is a very harmful, hazardous chemical, and it has been found in 80% children and almost all adults. Also, microplastics are mostly consumed by marine organisms because like a majority of plastics end up going to the ocean, right? We dump them in the ocean. So therefore, under extreme pressure, under extreme sunlight, UV radiation, they degrade and they become small plastics, which we call microplastics. And then they're eaten by maybe small fish. Small fish are eaten by bigger fish. They're eaten by maybe whales. So, has anyone seen that picture of a whale who died, and I think some tons of plastics came out? Does anyone know about that? Right? Anna is nodding. Would you like to share about that?
Like I guess it means that like because of people littering into the ocean, the like whale ate it because it thought it was food, but then like it actually died because it was like that toxic.
Right. So they die because the plastic which will littering is very toxic, right? Right. That's a very valid point, and definitely, yeah. So that's not good for the marine organisms. Also, these can affect the economic activities, basically activities which are not based, which are based on marine things, right? For example, trade in water by ships, right? That's based on marine things, fisheries, for example, which fish, right, which take out fish from the ocean. Microplastics affect these economies. Now, I have a question for you all. According to what we have seen so far, see, microplastic is a plastic, right? This is a small form of plastic. So, is it a thermosetting plastic or thermoplastic? Who can try answering that?
It's most likely thermoplastic since it says that when it's exposed under sunlight, it melts. It decreases in size and becomes as small as a red blood cell. That's the thing.
Correct. Very nice, very nice. Definitely, it is a thermoplastic because they can easily, degrade. They can easily tear apart and become smaller plastics. So that's very right, and that's very rightly explained also that yes, they are thermoplastics. So now we have seen the problem with microplastics. We've seen the problem with plastics, how they're treated. Finally, coming to bioplastics. Now, what are bioplastics? Why do we need bioplastics? Now, bioplastics, as the name suggests, bioplastics. So, bio means something which is very environment friendly. Sorry, right? Now, these are made of natural resources like vegetable fats and oils, cornstarch, straw, wood chips, right? The small chips of wood, the bark, basically, sawdust, recycled food waste. For example, the kitchen waste which we have, right? They, if left in the ocean, would break down into smaller plastic fragments or microplastics, just the way normal plastics do, right? But these bioplastics will take only 3 to 6 months to fully decompose, whereas normal plastics will take centuries. So if you want to try this out, the plastic which we'll be making today in the experiment, you can try burying that in the soil, right, with manure, and maybe after a couple of months, you will see it in very small fragments, or maybe in a few coming months, you will not see it there at all, right? So that's the idea of bioplastics. And there are two types, oxo biodegradable and hydro biodegradable, but that's just a bit too complicated, so we won't get into that. right? And yes, so bioplastics, now since we have the technology, why don't we use it? Firstly, it is not economically feasible, right? We can't like we would need a lot of expenditure to basically have it on a large scale. And secondly, uh, bioplastics, they are also emitting certain emissions like methane. So even though the quantity is very less, but they do emit some emissions, right? So there's nothing which is fully like 100% good. There are ups and downs. There are certain downsides to everything. So the downside to bioplastic is that it cannot be taken to a large commercial scale. It is not economically feasible, and it has some amount of methane emissions, right? Is everything clear till here? Guys, and I'm here, sure. All right, great. So moving ahead to some bioplastic, this is a very small concept about some types of bioplastics or how we can make bioplastics. So they are starch based, which is the thing we will be looking at right now in 2 more minutes. Bacteria based plastics are also there. Soy based plastics, cellulose based plastics. So cellulose is a substance which is found in plants, right? It is a chemical found in plants, leaves, barks, roots, etc. And even lignin, right? So lignin-based plastics are also there. So are we all ready to now start with the experiment finally? Right? All right. So coming to the experiment. Now, the materials required, they had already been shared with you: starch, cornstarch, water, vinegar, a stove, pan, spatula, and a flat surface, which can be a table or anything. And for those who have the materials with them, so you can like start with us, right? So if you're all just coming with like the things, let me know. Otherwise, I'll start. Are you all yet to prepare, or are you all prepared? Veer, Vivi, Ayana, are you guys preparing right now, or are you prepared? Can I start?
I'm prepared right
I'm ready.
Ready? All right, great. So, since we're going to work with a stove, it would be great to have parental supervision and take some help from elders. Now, you have the steps. If you want, you can take a screenshot of the steps for your reference, but I'll be showing you the video of how I did the experiment at our school laboratory, right? So this is how I did it. There's no audio. I'll be speaking with like as the video plays. So we took certain materials. This is some water, a tablespoon, a beaker, mixer, vinegar, cornstarch, and starch. This is all the material we took. When we also took a heating stove, so like a heating plate. At school, we didn't have like a proper stove, so we used a heating plate. Since you guys have a stove at your home, you can use that. So guys, now start with adding 1 tablespoon. 1 tablespoon is basically 15 ml, right? 15 milliliters. Add starch, 1 tablespoon. Yes, Avivek, you have a question?
Yeah, so will this pan work?
Hmm. Yeah, it will work, but if you have a smaller pan, that would also work because like this is too big for this. Like if you want to do the experiment on slightly large scale, you can maybe proportionally increase all the materials. Right? For example, if you have 1 tablespoon, you can use 2 tablespoons. Then you have to use each material twice the amount, right? So that's up to you. But if you want, you can use a smaller utensil as well.
I'll find a smaller one.
I'm sorry, I can't hear you.
Yeah, I'll find a smaller one.
Your voice is very unclear. Could you please repeat or maybe Type it on the chat.
I think he said he found a smaller one, so yeah.
Okay, okay, all right, smaller one, great. Great. So the first step is to add 1 tablespoon starch, 1 teaspoon cornstarch, 4 tablespoon water, and 1 teaspoon vinegar. And this is also there on the slide, right? So the amounts that are mentioned here, you have to take these much, like this much quantity, and you can add them all. All right. And if you want, you can proportionally increase or decrease them depending on like how much you want to basically make the plastic, right? You can make it 2 tablespoon, 2 teaspoon, 8 tablespoon, and 2 teaspoon if you want. Yeah, Abhivi, I think this is better. Yeah. All right. So 1 tablespoon, I repeat, 15 ml starch, 5 ml cornstarch, 60 ml water, and 5 ml vinegar. Yeah, it's also on the chat. Okay, you can mix all of these right now. Let me know when you're all ready to move ahead. And yes, one important thing: don't yet turn on the gas. The gas should be off right now. Turn it on later.
I have a question.
Hmm.
How much water do we need?
You need 4 tablespoons water, basically 60 ml. 60 ml water. Like consider it maybe 1/4 of a cup water. So has everyone done till here? Starch, cornstarch, water, and vinegar. Basically, the next step is to start mixing. So I just continue. All right. So you can mix them properly, and then keep them on the heating plate or the stove, whatever you have at your home. And then one important thing is to keep on mixing, right? Don't stop mixing, even if it is on the stove. Keep mixing, right? And continue until you form a sort of gel-like substance, right? So right now it is purely liquid. Keep on mixing until it becomes a gel. That should come very soon, right? It won't take you a long time, maybe 2 or 3 minutes, and it should become gel-like. And this is how it would look like. So guys, everyone just pay attention to this part, because this is where you're supposed to stop heating, right? This is how the gel-like substance will look. This is how the consistency will be. You guys can update me how much have you done till now, and I will accordingly guide you and continue.
How thick it will be for the gel?
Yeah, so you can see consistency from this part. This is how thick it should be. All right. Yeah, like this. Basically, maybe you can say the consistency of your toothpaste, right? Utna.
Okay.
Okay, then I see you're doing the experiment. You just started heating, right? Okay, all right. Keep heating until it becomes gel-like.
I have also stopped the gas because it has become the gel now.
Okay, great. So I'll just guide you how to move ahead because you shouldn't let that just cool down. So as soon as you take it off the gas, maybe after a minute or so, with a spatula, right, spread it onto a flat surface like your table, the kitchen slab. Just spread it, all right, and spread
Like
it very
this,
evenly.
like this one.
Yeah, this also works, but I think you can take a maybe surface which is totally flat and इसमें ऐसा कुछ मतलब not like a plan not like a pan because you have to scrape it off. Okay, so you need some some space to use your hand to scrape the plastic off.
Okay.
Right. So listen to this carefully. The plastic, sorry, the spreading should not be thick. All right. Flatten it as much as you can. Not ki there are spaces. Okay. Avoid spaces. Avoid air gaps. But spread it as much as you can because I have my plastic with me right now. This is the plastic I made at school. So the edges of the plastic, they're very smooth, they're very even, but the middle part is very uneven because the middle part was I didn't spread like very evenly. This is how the plastic. This is how it came off for me because the plastic had already come off before I went to take it off. So uh, it is even when you take it off, but it was an exception.
I have done the spreading.
Okay, could you just show it on the camera? How have you spread it? Because okay, I would recommend you spread it even more, even more.
Okay.
Yeah, continue spreading until it becomes very thin, right? Very thin there.
My mixture hasn't become gel-like.
And I think you should spread on both ends. Like Abhi, you're doing horizontally, you spread vertically.
Okay.
If you're saying something, you're very far away from the mic, so we can't hear you. You have to come closer.
My mixture hasn't become like really gel-like yet. I've been mixing it for a while.
Okay. Do you think you added a lot more water than what was required? How much water did you add?
Mama added 4 tablespoons, around 4 tablespoons.
Okay, and what about the other things? 1 tablespoon of starch, is it?
Yes.
And 1 teaspoon of cornstarch. And vinegar as well, 1 teaspoon. Yes? Did you add vinegar, Abhivi?
Yeah, I even added vinegar.
You have.
I added enough vinegar.
Oh, you don't think you added enough, are you saying?
I don't think I added enough.
Okay. If you think you didn't add enough, just complete the amount. Yes, Ayana, you have your hand raised. Angad, you want to address her question?
Yeah, I just wanted to ask if this is fine.
Yeah, I think this is good. You could spread the corners a bit more.
Okay.
It looks well spread. It's fine.
Is mine fine?
Yeah, it's good, but I think when the plastic hardens, it'll be very uneven. Like it'll be in layers. If that's fine, then go ahead because the thing is, I think spreading it too much. I think you should leave it as it is because was it gel-like when you took it off? It seems as if it was more liquid.
It was like this.
Okay, yeah, it looks all right. Yeah. I think it should work then. Yeah, even Ayana, I think yours is also fine. It should come up with. So basically, you should wait for around 15 minutes or so, right? And I'll show you a few pictures of how it looked later on. Again, I'm repeating, I didn't scrap it off very well, so it is very uneven. But this is how the plastic really comes like. And if you not if you notice, the texture is much like your notebook covers, right? Your plastic notebook covers. I have the plastic with me also right now. So this is the plastic, how it came off. Not considering how it was taken off, but the flat parts are quite flat, right? They're very even. If you are able to pull it off properly, then well and good, and you have your plastic all right. You should let it.
Should I switch on the fan so that it will like dry up?
You can, yeah. Yeah, you can. It will still take around 15 minutes, but might take 10 with the fan. Not sure. So
Okay.
yeah, just let it dry for around 15 minutes. If it is thick in some areas, then don't pull it off. Like for example, I'll give you my experience. Like I'll share my experience. When my plastic was very like when my gel was very thick at the middle, it took around 2 days for it to dry. But the corners would dry within an hour or so. Like even they were very even they were slightly thick, but overall the plastic came out very well. So it may take more than 15 minutes as well. Just be prepared for that. Thing,
Okay.
yeah, the thing is just don't touch the liquid part, otherwise it will spoil uh, the hardening of the plastic.
Now my liquid still hasn't become gel-like.
Abhivir, is that you? All right. Yeah, okay, Abhivir. So probably there was some error while in the proportions while you were measuring. Okay, so that could have been one of the reasons why it didn't come the correct consistency. What you can do is probably, after the call, try it one more time. Look at the list of ingredient, like exact amounts are in the chat, and you know the process. So just try it one more time with the exact um, proportions. Okay, so probably then it would come out nicely. If it doesn't, then what we can do is probably, one of the days next week, we can try it out in the school lab. So you can reach out to me or Angad, and we can see if we are free in a common slot. We can come together for 15-20 minutes and try doing it in the lab and see where we went wrong. Yes? Yes,
Also,
Abhi? Yeah. Go ahead.
yeah, also the heating also impacts the plastic. If you heat it a lot, it will become very gel-like. If you heat it less, it will remain like very liquid. And therefore, it is also important to keep on mixing while it is like on the stove. yeah, if it still does not work out, you can definitely reach out to us and we'll arrange for the experiment in the lab. So since it may take like a bit long to dry, for now that's all from my side. Thank you very much. If you have any doubts, you can ask right now. For now, I'll hand over to Tulshi.
Hello, everyone. It was so good seeing you all practice Ayana, Mihir, Abhivir, especially the others. I don't know whether they were trying it out while their cameras were turned off. But
I couldn't try it out, but I did see the other people do it.
all right, Shradha. So probably when you have the ingredients, or you can come to us in the lab and we can do it together in school sometime. Yeah. Even if you saw the procedure right now, which is great. And I can see Ayana so desperately wait. Are you waiting for it to dry? Yes. Okay. And Abhivir, I hope you will try it one more time after the call or whenever you get some time over the weekend, right? Thank you so much, Angad, for leading us through the session. It was quite interactive. So before we close, I would really appreciate if all of you could put a couple of sentences of feedback on the chat, or if you want to unmute yourself and share on how did you find today's space, any feedback for us with respect to topic, with respect to facilitation, it would be great to know. You can unmute yourself or also put on the chat, whatever is feasible. Yes, Ayana, please go ahead.
So I really enjoy these kind of sessions where we have to work in the kitchen, and I learned a lot about plastics and microplastics and bioplastics.
Great, thank you for sharing. What about you, Mihir? Mihir or Abhivir or Daksh, Abhijay, Pranil, anyone would want to share? Someone's sharing that Angad facilitated really well. Absolutely, 100% agree. Anyone else would want to add something? Yes, Pranil.
I have a question. Like
Yes, please.
when the plastic dries up, how to scratch or take it off? Like how
Angad,
will
do you
you?
want to answer that?
Right, yes. So you can take any, so for example, I'll give you, okay, maybe a scale, right? If you have this is just a plastic one, if you have a metal scale, you can even use that to scrape it off. Scrape it off very thoda sa aram se, because it may tear the plastic. So don't use something very sharp like a knife. So don't use a knife, and don't use something very blunt which will not scrape it off. Maybe a scale, maybe if you have maybe a metal piece, maybe, right? Or maybe if you do gardening at your home, if you have that, like in Hindi we call it khurpi, if you have that, you can scrape it off with that.
Okay.
Or even like in the lab, we also have a metal spatula, so which is flat on one side. So you probably would have a spatula at home also if it's used, like not the silicone one, because that's usually thicker, but the metal spatulas are thinner and flatter. So if that is available in the kitchen, you could use that. All right. Thank you so much, Abhivir, for sharing. All right. Anyone else? Pranil, you had your hand raised. You want to go ahead, share?
Yeah, I want to say great session. Like it was like I could see some of the students like they were doing the experiment quite enthusiastic. So yeah, I'd say very, very well conducted. Nice, good job on it.
Thank you so much, Pranil. Oh, yes, absolutely. Yes, yeah, everyone. It's a great suggestion. We could use something that's flat or a plastic sheet and open it up and then, lay it on that and then peel it off of that sheet. That's also a great suggestion. Thank you for sharing that, Angad. And all right, okay. So thank you so much, everyone. It's also time. So we will close here. Next week, Pranil, do you want to share what topic we'll be working on?
So yeah, actually I kind of set up something, so I would not want to reveal the exact
Okay.
topic of the session.
Perfect.
So yeah, it'll be a
Sure,
surprise.
sure. Okay, so then we will let that remain a little under covers for now. But
Ma'am, should I share the materials required?
yes, you can put that on the chat, Pranil. So as Pranil puts the materials required for the next session in the chat, one thing to note for you is that the session would require dry ice, okay? Now dry ice would be available in a lot of ice cream vendor carts. It's available with them. But again, when you're using dry ice, you have to be very careful. Make sure you can have silicone gloves that you can purchase and put them on before you use dry ice. You cannot hold it with your bare hands. And whenever you're using it, please, if you do get hands on dry ice, please please have some elder around you who will be guiding you through it. Okay, just like today we saw Abhiveer, the parents were helping him, or even from here, I think. So please make sure you have some supervision while you're using that if you're able to find dry ice, okay? And yeah, it would be available with the ice cream vendor carts. Usually that's where you can find them. You can like, on the same day that you are doing it, or you can probably get it a day in advance and put it in your freezer. Okay, but again, please use gloves to use it. Yes, Mihir, you have a question?
So is this dry ice?
No. This is not dry ice. Dry ice is solidified carbon dioxide. Okay, you can just Google that and find out what it is. Okay, and you can, see where it's found.
And as ma'am said, make sure to use it while wearing gloves, or else you might get a frostbite.
Yes, because it's very cold. It's colder than ice, so we can't hold it. Would dehydrate your fingers and you can get a frostbite. So make sure we're using
You
gloves.
can get a cold burn, like a cold burn. Since
Yes.
of sheer like how cold dry ice is, you can actually get a cold burn due to
Yes,
the.
correct. Absolutely. So cannot use it with bare hands. If you're able to get your hands on dry ice, please bring it. If not, even then it would be a fun session, an interactive space for us to learn something. And then you can probably, hop into the chemistry lab at school sometime, and then we can try it at school also. Right. So whatever is feasible, would really recommend you to have these things. And centrifuge tube is available in the lab, but I will just, with the next email, I'll send a photograph of what it looks like, okay? So you won't be able to arrange for a centrifuge tube, but what you can arrange for is an object that looks similar, okay? Right? So that's what we'll do with the centrifuge tube. We'll just attach an image when we send the next invite, okay? That will be by Monday, Tuesday, we'll share the invite. So then you will have some time to arrange for the items, right? I think the other materials will be easily available. Yes. If you don't find filter paper, please go to any of the labs and ask the lab staff for a piece of filter paper and take it home in your notebook and use it over there. Yes? Cool? Great. All right. So I have shared about the objects, dry ice have shared, filter paper. If you don't find it, please take it from the labs and then take it home. Centrifuge tube, will send you an image so you can check. Plastic beaker is nothing, any plastic utensil at home, which is narrow, will do, narrow and long. Okay. And so even like a takeaway box of something will also work here. And copper wire again should be available somehow, somewhere you will be able to find it for sure. All right. So we will close this space here. Thank you so much. And we will see you all next week. And if you like this space, please ask your friends to register. The Google form is still open. We can have them the next time and they can also have their share of fun and learn something new. Yes. Take care, everyone. Have a good evening. Take care. Bye-bye.
Goodbye.
Bye-bye.
Thank you, everyone.
Bye, ma'am. Thank you.
Thank you,
Everyone,
everyone.
goodbye. Thank you. End the call here.